Welcome to Geometric Virtual Learning. In today's lesson, we'll be talking about reciprocal graphs. If you have not subscribed to this channel yet, please subscribe to the channel and share with your friends and hit the notification button. Thank you. In this lesson, we'll be talking about features of reciprocal graphs, and we'll also go through how to draw reciprocal graphs, and also we'll know and understand the shifts in vertical and horizontal asymptotes. Let's look at the features of reciprocal graphs. First, the general form of a reciprocal graph is y equals k over x, where k is a real number and x is not equal to 0. Okay. So this is a typical example of reciprocal graph, and it's in two sections. X cannot be 0 because we don't want the denominator to be equal to 0, because a number divided by 0, you won't be able to define the value of it. That is why there's the restriction. X cannot be equal to 0. So remember, when you are having to draw reciprocal graphs, think of the restriction. At what point you will not expect the denominator to be equal to 0. So when it's simple like this, x cannot be equal to 0. Now let's look at the features. Look at the first quadrant, this section. Now you see that as the graph gets closer to the x-axis, x coordinates are also getting bigger and bigger. So which means that the x coordinate can get bigger and bigger and bigger, and the graph will be getting closer and closer to the x coordinate, x-axis, but will never touch the x-axis and will never cross it. So we say the x-axis is becomes what we call the horizontal asymptote. Now I want you to understand some terminologies here, and I'll be using them interchangeably. X-axis is called y equals 0. So when you hear me say x-axis or y equals 0, they mean the same thing. Y-axis is called x equals 0. So no, x-axis, y equals 0, y-axis, x equals 0. So we see in the first quadrant, the x-axis or y equals 0 is called the horizontal asymptote, because the graph gets closer and closer to the x-axis as the value of x coordinate increases. Conversely, as x values get smaller and smaller and smaller, the graph gets closer to the y-axis or x equals 0. So we call this the vertical asymptote. So we can say that when you draw a reciprocal graph, you see that the graph will be asymptotic to both the x-axis and the y-axis. In other words, the graph will be asymptotic to both x equals 0 and y equals 0. X equals 0, y equals 0. When you come to this section, to the same thing, asymptotic to both y-axis and x-axis. Now, this is the positive section of the graph. This is the negative section of the graph. It is not joined simply because our x cannot be 0. That's why it's disjoint. Okay. Now let's look at an example how to draw. So we first have to compute the values for y given the x coordinate. This is shaded because we're not going to plot it, because we don't know the exact value. So negative 2.5 with x will give us negative 1.2. Work out all of them, and we plot the first negative section first. So that's our graph. Let's plot the second section, positive side, join with a smooth curve. So we can see that both curves are asymptotic to the x-axis and the y-axis. Again, both curves are asymptotic to y equals 0 and x equals 0. So we have vertical asymptote, horizontal asymptote. Now try this yourself and see if you can compute the values. Let's check the answers. Try and see if you can plot it. You need to just pause the video and do it before you continue. Okay, let's see. Also, you can see the graph is asymptotic to both y and x axis, or the graph is asymptotic to both x equals 0 and y equals 0. So note the keywords properly. Here, we're supposed to draw the graph of y equals -2 over x. So we put in x coordinate, which is -4, -3, and so on. So you're going to have let's plot the negative section. Now the positive section. Now do you see any change? Yes. The previous examples we had in the first and the third quadrant, but now we have the answer in the second and the fourth. Can you think of a reason why? Because of -2. The ones we had before were positive numbers as a numerator. That is the reason why. So make note of this. But still, both graphs are asymptotic to the y and the x coordinate. So both the graph that we've drawn is asymptotic to the x axis, or y equals 0, and it's asymptotic to the y axis, or x equals 0. So that's the horizontal asymptote, vertical asymptote. Now let's look at what will cause a shift in the horizontal asymptote. We now have y equals 2 plus 3 over x. Let's work out our values and let's plot first one, second one. Okay, something has happened. Right, you could see that the graph will get closer and closer to the y-axis, or x equals 0. You can also see this will also get closer and closer to the y-axis, or x equals 0. So there's no change in the vertical asymptote. But what has happened to the x-axis? If you carry on, this graph will be getting flatter at this end, which means it's getting closer to y equals 2. That one too will be getting closer to y equals 2. So there is a shift in the horizontal asymptote from y equals 0 to y equals 2. And the reason is that we are adding a whole 2 units to the typical 3 over x graph. Because the typical 3 over x graph will be asymptotic to the x-axis. And because we are adding 2, we are shifting the asymptote 2 units up. And remember, that's the reason why there is a shift in the horizontal asymptote, but the vertical asymptote is still the same. In our next example, we'll see what will cause a shift in the vertical asymptote. Here we have y equals 3 over x minus 1. Let's work out the values. Let's plot the first section. Now, before we plot, you realize that in previous work, we don't even compute for when x is 0. But this time, we rather compute for when x is 0, but we didn't do for when x is 1. The reason is that I said from the beginning, for reciprocal graphs, the denominator can never be equal to 0. So, if x is 0, 0 minus 1 is not 0, so we can have a section there. But when x is negative when x is positive 1, 1 minus 1 gives you what? 0. So that is where we can't have that restriction. We can't have that to happen. So there's a restriction. Says that x can never be equal to 1. And that will lead us to explanation of the asymptote. So let's plot. First section, then second section. Okay. Now, let's look at the horizontal asymptote. You could see that they both getting closer to the x-axis, which is y equals 0. So that one, no problem. No shift in the horizontal asymptote. But look at what is happening. They're going to go down all the way here. So they're going to get closer to this line. And this line is called y equals 1. Y equals 1. So you see there's going to be a shift in the vertical asymptote. It will move from x equals 0 to x equals 1. The vertical asymptote will move from x equals 0 to x equals 1. So there's a shift in the vertical asymptote. The reason is that we are what? X minus 1. It works in the opposite way. When it's minus 1, it shifts 1 unit to the right. When it's plus 1, it shifts 1 unit to the left. So you need to understand that. When it's plus 4, the vertical asymptote will shift 4 units to the left. When it's minus 4, it will shift 4 units to the right. So the reason is that we don't want x minus 1 to become 0, and that becomes 0 when x is equal to 1. That is why the asymptote is x equals 1. So this graph is asymptotic to y equals 0 and x equals 1. But like I said, the horizontal asymptote will still be the same, the x-axis, or y equals 0. And that brings us to the end of lesson on reciprocal graphs. Hope you've enjoyed it. Look forward to the next lesson on exponential graph. Thanks for watching.